Everyone, we are now moving to a highly anticipated part of our conference, a distinguished lecture by Mr. Xavier. It is my pleasure to invite Mr. Xavier from Dassault Systems onto the stage to deliver his lecture on Design in India, Design for the World, Beyond an Inspiring Phrase, a Roadmap for the Workforce.
Good morning or good afternoon, I don't know yet. I'm a little bit time lagged. I'm low in sugar, I may faint, so don't worry. If that happens, put some sugar in my mouth. It's a very... I was so happy when I learned the new theme of the Prime Minister of India, because that's the right next step to make for the country, not for small things, but for the prosperity of the country. So this is why I had the audacity to not use the word AI in the title of this presentation. We have to look at the purpose. We are absorbed by technology, we are providers of technology, but we have to never forget the purpose. And this is a good purpose, not just for industry, but of course, more obviously for education. It is about attaining economic sovereignty. This combination of words, economic sovereignty, is something that you hear very strongly since the COVID time. Because there has been countries, take my own country, France, where we had an issue with masks. We had no productions of masks. And you may remember there was a kind of war to get the first masks, just because there was no... So this is sovereignty. Sovereignty is having inside a country whatever you need to prosper, or at least to survive. So these are things that we should inculcate, we should tell our engineers, our students, that they should keep that in mind. It's about mastering design, and not just design. You don't design for design, you design for the purpose, an economic purpose, whatever. So there is an entire science, an entire engineering that is required for the monetization of design. And that includes manufacturing, distribution, maintenance, recycling. Internationally. The definition, so who is, the European Union is the most concerned by this notion, because you know Europe has no big natural resources, and we are very concerned about that. The aerospace industry, but that's not just in Europe, suffers from the scarcity on the market of titanium currently because of the embargo on Russia. So this, for economic sovereignty, means you have everything you need to continue to prosper. If something happens, you must be really resilient. That means if one of your suppliers somewhere on the planet is failing for whatever reason, you must be able to switch to another one in an agile manner. And that can mean a lot, qualification, etc. Engineers, what are they doing? I think I have a laser pointer here. Is that a laser pointer? No. There. Engineers are in your schools. Engineers are essentially focusing on design. Why is it so? Because it's cheaper to train design engineers than manufacturing engineers. Manufacturing needs to train them with machines, having some expensive equipment that you will need. In any case, if you want to go there, you will need manufacturing equipment. But when we look at the engineering work itself, it's constrained by production, by manufacturing. Good engineering that you can export, must be a good quality engineering, and therefore must be constrained by manufacturing. It must be constrained by distribution, because things you will sell in one country are not the same as the one you will sell in another, just because, for instance, sustainability regulation is not the same. And that is an important thing. Your engineers have to understand that engineering is all that. Of course, they will not become specialists in all these domains, but they have to understand that what they do here is constrained by everything else, and have a notion of that. For us, providers of tools, digital tools to do on the computer all the engineering that is described in all these steps I was showing, it means a lot of consequences. Everything must be connected. The data you produce in engineering must be usable in manufacturing. Further, it has to be used in maintenance. And, well, later on, this morning, when I came from the Marigold Hotel, I saw some people wearing uniforms from a company, Sidel. And I asked them, what are you doing here? And they told me, Sidel is a French company, it's the world leader of machines for beverage packaging. And they told me they were here to install a factory for Coca-Cola. So that means, and they were not French, they were all from Philippines. So we have Filipino people coming here to install a French system. How Indian is that? So the operation of that system will be done in India. But the continuity and the control of the entire process is not in India. That is the problem. When you look at design, you have many facets in design. Traditionally, people jump on the emotional, the creative dimension of design. The quasi-artists. Quasi-artists are used to ignore what if their product is manufacturable. They're also used to ignore if it's maintainable. They don't care so much about sustainability. It has to be beautiful, appealing, sellable, attractive for the customers, which is not a bad thing, but it should not be the only one. It should not be at the cost of the other dimensions of design, which are considering the experience of the user. How will they interact with that thing that I am engineering? The context. And the context required a description of the entire surrounding system. And the tools for that are systems engineering tools. The methods are systems engineering methods. Don't believe that these are only things that are necessary in aerospace or in defense. Systems engineering is a meta description of the functional behavior of things and how they interact. There are tools in that platform that is called the 3D experience that I am talking about that are doing exactly that. Performance. We are not Hollywood. The things we design on the screen have to exist in the reality at some point of time. So that means if we want to validate these things, we have to consider the real physics of things. And therefore, the design process has to embed the simulation of the physical behavior of these things. And that means finite element modeling, means structural strengths, it means acoustic, it means whatever, flow simulation, all that has to constrain the design. And finally, life cycle assessment. If we are in a world where we consider the the impact, the environmental impact of what we design, we have to consider all the events that will happen during the life of that thing that I am currently designing. And that is called life cycle assessment. There are tools to do that. We rely on a huge database that was developed. It's the largest database for life cycle assessment in the world. It has been developed by a university in Switzerland, EPFL, and it is updated continuously. So, and this is made possible because we are speaking about cloud work. You don't care about changes. The changes are somewhere on the database that is in Switzerland. So multiple dimensions of design. Some are emotional, some are functional. AI. AI will intervene and accelerate a lot of things. I have here to show you the dynamic of before AI, after AI. Here are two examples of architecture. These two projects are using the platform that I am talking about, which is a 3D experience. One is by Frank Gehry, and that's the Bilbao Museum. The other is by Kengo Kuma. These are both star architects. Kengo Kuma has designed a railway station near Paris that had to open for the Olympic Games. It was a new line that were created for the Olympic Games. In the first case, and they are both covered with tiles. All these tiles are, each of these tiles is similar to the next one, but a little bit different. In that case, it was all the titanium tiles on the museum. In that case, it was ceramic tile. First case, 42,000 panels, what are called tiles, of 20 different types. In the second case, 6,000, but 1,000 different types. This design was possible because manually, one by one, because they had only 20 types. In that case, they had 1,000. They had to use AI to generate the variations of the tiles, the different versions of the thousands of tiles they had to design. Other little change between these two dates, 97 and 2024, little change, the arrival of cloud. In that case, in that case, the first case, they used faxes to exchange between the participants. The number is here. In the other case, they used cloud. That means everyone was instantly aware of what the others were doing. Generative design is the application of AI that generates shapes of objects that satisfy physical conditions. So we need constraint. We cannot tell the system, suggest me something nice. It will, but it has to be something physically valid. So this is, you can generate shapes, different shapes, under scientific constraints. Production. If you think about Industry 4.0, be aware that the Industry 5.0 is currently a very hot topic in many places. What is it? It's not so different. It has been very strongly formalized by the European Union Commission. They have their definition. Essentially, it's about putting the human at the center. The human being the user, but also of the final product, but also the operator. And that's why in the engineering process, you will have to take care of how the operator will interact with the machines. And you can imagine the psychological impact of someone working together in that example, that is collaborative robotics. Imagine you are the worker, all day long you work together with a machine. You end up feeling as a servant of the machine. How to change the workplace in a manner that mitigate this problem. So there are currently works going on in universities about the psychological impacts of this situation where a worker is collaborating all day long with a machine or a robot. Manufacturing is complex. Machines are complex. I was mentioning the coincidence that made me meet this morning with a company making bottling machines. And this is it. I had prepared that before I met them by chance. Now this is from this company. It's a bottling machine. So needless to say that it's not simple. I am not saying that in each of your colleges you should have a big bottling machine installation. I'm not saying that. But I'm saying that you have to prepare your students for complexity, for this complexity of manufacturing. And the best way to prepare it is by giving them the experience of the factory. More and more we see learning factories, and here is an example of one that is near Paris. If you come visit me, we can go there and we can go see how it works. There are other such factories across the world, of course. But I advertise this one because I try to attract you in Paris. This is used for multiple type of training. Students, for imagine master students, undergraduate, high school. They have visits of high schools. The visits that can last 1 week, full week. It's called an internship. 13 years old are the students. Professionals, industry leaders, CEOs who think about modernizing their processes. And last I mentioned is sustainability. It's a little constraint that comes on you in addition to the ones I had presented. For us, Dassault system is very natural, because if you read our corporate purpose, we are obsessed by facilitating the work of those people who will help us survive in a few years, few decades. Let's be optimistic, few centuries. And these people are your students. So sustainability is a subject that we can bring into the learning activity with these tools, with this platform. It's called the 3D experience. And if you want to learn more, because as soon I will hear the bell about this, we have a booth, and we have two colleagues here, Rajit and Renuka. Can you stand up so the people know to whom they can ask the questions? They are not here? They are not interested? But anyway, come to our booth if you have questions. Is the tradition, I would say, of scarcity something that prepares some country better than others? If you look at the rate of recycling of polymers in different zones of the world, I'm sorry it doesn't appear, but you distinguish the zones. The best rate of recycling of products that are locally consumed of polymers is India. Why so? Because you have a tradition, my interpretation is a tradition of dealing with scarcity. It has also something to do with Jugaad, which is one of my preferred subjects. So this prepares a little bit your students in their mindset, not in their industry practices, but in their mindset. Jugaad is not industrial, but Jugaad is a mindset. Cultivate that. Do not forget Jugaad when I'm out of the room. I'm convinced it will help many places in the world to adjust with the climate change. Because now, if we want to consider also sustainability, you have to think about the second life, the third life, the fourth life of the product that you are today designing. You are not optimizing your design for selling it and forget it. You are designing it for all the cycle and until you have collected it and until it is dismantled. And that requires that you have to engineer a process to collect, a process to disassemble. And disassembling is not just the reverse of assembling it. It's just a button to push and operate the factory in the other. There are disassembly factories on this planet. And here are some examples from universities, how they work with this subject of sustainability that, of course, include lightweight engineering practices. Lightweight is the first way to save material we use, to save the energy that moves the vehicle, because it carries less weight. And this is an engineering practice that is emerging and that is very important as a dimension of sustainability that is well developed in the curricula of this university in Germany. Here are more examples, an example of student projects in Technical University Delft, where they have built a hydrofoil fuel cell powered boat that goes high speed between Netherlands and UK. Students, professional grade. So that is the luxury, it's a luxury version of a student project. But to do that, they needed to do two key things. The system engineering of this thing. It's electrical, it's mechanical, it's hydrodynamic, etc. That is multiple functions that had to be optimized together. With that, they could, to do that, they were using one of the few systems on the planet that is integrating all these computer representations of all these phenomena, which is this 3D experience platform. Last example from a university, there is, in most of the schools, your students do Formula Student cars, and the Swiss team of EPFL was the first one in that competition, having a team focused on sustainability. So they designed their car with consideration of sustainability, using that technology that I was describing before. Virtual twin is the general term to describe that we want to create computer models that are physically valid of everything that happens to a product and connect that model with the reality. To help you educators on this transformation, we provide applications, we provide content, learning content, course material, constantly up to date on the cloud. We provide services, communities where you can interact with zillions of other educators on the planet. We provide also two labor programs. One is certification of individuals, micro-credentials, and the other one is centers of excellence. We have virtual twin. So I said we provide solutions. Solutions are the virtual twin solutions that are illustrated here, just to give you a feeling of the domains of application. It's not just making mechanical parts. And the virtual mockup, the virtual twins, has itself multiple dimensions that I will not comment for the sake of time, but we can have a discussion whenever you want on the booth on these dimensions. Multiscale is just telling we are modeling at nanoscale quantum interactions, not Newtonian interactions. And then context points on systems engineering, taking into account the context means system engineering, etc. Sorry, I do not comment that further because I start to hear the bell. The domains of applications are the industries that you see on the right. The products are typically design products like CATIA or SolidWorks, manufacturing design products like Delmia, simulation products like Simulia, and for those of you who are mechanical engineers, if you don't know Simulia, I am sure you know Abacus. Abacus is part of Simulia. And again, on this subject of products, I invite you to have whatever conversation with my colleagues on the booth, or if we disappear before the end of the conference, you have our contact. You know how to contact. Ask Krishna, he will tell you. And at the end, I think I have put my email. In terms of educational content, we are starting a new style of providing educational content, which we call education experiences. And so far, we provide such experiences on those 7 domains here, but we are preparing the next one. There will be more and more. These are online content that you at any time can use as a user of our system. You can download that. You can download it. It means you can adjust it, adapt it to your own course. And it's composed of many components. And the other instrument, micro-credentials, a way to facilitate employability. The debate in India on employability is never ending. If you, instead of arriving to an employer just telling I am coming from whatever college, you can add to your curriculum vitae, you can add the very specific certificates that relate to the job you are seeking. And the last instrument we have, because we know there is a lot of expertise to develop around all these notions that I have mentioned, we focus our efforts, we collaborate, we inject more and more expertise as often as possible into places where we know they verify a certain number of seriousness criteria, serious in the way they understand the role of digital technologies in engineering. 2 minutes, okay. I will be 2 minutes late. Because that's the last slide before the 1 hour video. The last instrument we have to help your colleges to start new inspiring projects is our foundation in India. They are funding projects. One of them is Connect Next, which is a way to provide your students with industry relevant activities that we are mentoring, and that they can check as a valid internship in your new ICTIEE rules. The sound was not exactly the one I expected, but this is just to give you one little example of a startup in India that has been using this 3D experience platform to start their business of electric scooters. This is what their chief product officer said. And I think it's very wise. It's something that I would totally subscribe to, and I invite you also to think about in your own vision of design. With that, I will please my good friend with the bell.
Thank you, sir, for delivering an insightful lecture. Your expertise and perspectives have truly enriched our understanding, and we deeply appreciate your time and effort in sharing your knowledge with us.